All right, welcome back. So here we are. We're in the third video for Module 11. So we dealt with data acquisition briefly. Talked about different ways to get data into our program. And we brought it into a data frame. From there, we talked about wrangling the data. Before we wrangle it, oftentimes we're going to want to clean it. Let's go talk about data cleaning. Now, just because we've got far more cells in this doesn't necessarily mean that it's going to take that much longer to get through this one. So essentially, cleaning in some respects is similar to wrangling, but in essence, there's four things that we want to do. We want to get rid of errors, minimize any cost that's associated with errors in the data, improve the integrity of the data, and ensure the highest quality of information being derived from this data. Now, what are some of the things that can be wrong with this data, and how's data wrangling different than data cleaning? Now, in a roundabout way, it's the same but a little different. Cleaning focuses on removing stuff that is inaccurate, maybe outliers. That's something that's going to throw off whatever we're going to do. Data cleaning focuses on the accuracy and the integrity, and data wrangling more focuses on the structure of what we've got left. So if we do the cleaning first, once it's all clean, then we go wrangle it and deal with the structure. So think. There's a term called, I don't even know what the name of it is, but I use the phrase quite often. Function before form. Form is what it looks like. Function is what it does. So let's say you had no money and you needed a way to get to work. And I said, I have two cars that I can give you. I'll give you one of the two, and you choose which one you want. One is a 1997, no, not 1997, 2017. It's a 2017 Mercedes-Benz. It doesn't have any engine in it, but it's immaculate. And the other is a 1999 Honda Civic that runs phenomenally, but it's dirty and beat up. Which one do you want? Now think about, why do you need that vehicle to get to work? Choose which one you want. Do you want the one that's nice and clean, or the one that's dirty? One will get you there, the other one won't. These are the kind of things we've got to think about when we're dealing with data. We're talking about cleaning. Can this data answer the questions that we need it to answer? I can always clean that old Honda, and it won't cost me much, if anything. The Mercedes, no engine, there's going to be an expense, there's going to be a cost associated with that. So I need to start by getting something that functions. I need to make sure it functions in the way that I want it to function. So I'm going to go through and clean the data and make sure the questions that I would ask, I can actually do that work and ask those questions. So when it comes to data cleaning, let's go deal with that using NumPy and Pandas. So we've got a couple of libraries we're going to utilize. And we dealt with Pandas already, and we've dealt with NumPy already. So there are 6 different steps that we're going to go through. First, we're going to import the libraries. We're going to go get our data set, find anything that's missing, look and see if something's duplicated. Find out if there's any outliers, things that, yeah, that doesn't count. And then when it's all said and done, we're going to normalize the data in some form. Now it's similar, but not quite similar to the normalization I was talking about before. And I'll talk about this in a minute. So let's go look at this. We're going to import the libraries. Straightforward. Boom, I run the code and imported those. They're there. All the functionality's there if I need it. Let me go import a data set that we're going to use. And the data set I'm going to use is that one that I've got out in my Google Drive that has credit information. Is the person a student? Are they married? What's the balance of their accounts? The gender? What's their education level? Their age? How many cards do they have? What's their rating? And what's their credit limit? Ooh. What do they make? How much money do they make a year? So based on this, I can go through and statistically come up with a probability or a credit risk rating for each one of these individuals based on whatever things are important or found to be important. So here's a bunch of data that's been pulled in. And I may or may not have a problem with this data. We'll go through and we'll look to see if we have any data that's missing. So it's in a data frame. And that's something that we've done or showed you before. I pulled the head on it. I showed 10 values, 0 to 9. From there, I want to see, is any of that data in there null? So I run the isNull method, and it goes through and it will look to see if there's a null value in there. If there is, it'll say true. If there's not, it'll say false. And then I go add up for each column how many are null. So there's the isNull sum for each column. Boom, there it is. I see that for each column there are no null values. If there were, I would see which columns they were in, and then I can go address them. There's different ways I can go about addressing them. I can put something there like we did before. So input the missing data, or we'll just get rid of that one. We'll get rid of that record. I don't want that record in because it's compromised. There's something missing there. So to drop it, well, I'll go through and here's my data. I see it. And I can go through and drop specific ones. And whatever it is I want to drop, I'll go through and what am I dropping? Well, here I dropped age and I dropped gender. So when we look at this data frame, we drop those columns out. I don't even need them. If there's stuff missing out of them, just get rid of them. They're not that big of a deal. That's one way. I could drop the records or I could drop the columns. And in this instance, we dropped the whole column. The other way, I go pop those rows out. So there's one way. Another way is Well, let's go into those columns where something's missing and put something there. Now, if I already went through and did this and removed that column, this isn't going to work, because if that column's gone, like gender, we pulled gender out. And if I went and did this for gender, it wouldn't work. But since it's there, I can go through and fill in any of them with no cards. So if they, where it says cards, if they didn't have it, I'll put something in there. Now, another thing that's important is to know, is something a duplication? It will compare each row to every other preceding row. And if it finds duplication, it will let you know how many duplicates exist. We went through, and I could go do the sum, and it'll tell me how many there were. But with this, I said, look, go find and drop them. If there's any duplicates, let's just get rid of them. Because I don't want the same value being counted more than once. Because these are supposed to be unique records. I don't want information about the same person more than once. So with that said, we went through, we dropped the duplicates, they're gone, and it'll tell us how many rows we have now. And then lastly, we detect outliers. And now what's an outlier? Well, outliers are what we would call a statistical anomaly. And if we're looking at things that are statistically significant, I'm looking for trends over time. Let's say we're looking at an exam. Let's say it's a calculus exam. And the scores on this calculus exam, statistically, they average around, let's say the average, the median and the mean is 65. And the standard deviation is like 3. Essentially what that means is there's not a lot outside of that number, 65. And if we look at it that way, and then all of a sudden one person got 100, is that score of 100, is that a norm or something that's normal? Are you looking to see hundreds in there? No. Well, how about a 5? Is that a normal score? No. Well, I can go through and get rid of those. Those are outliers. Those are maybe somebody had a bad test. Maybe somebody is retaking the course or cheated on the on the exam and got the 100. If I get those outliers out, remove them, then my data is more reliable in predicting future scores. And that's what I would go through and do. And I could sort things out based on certain values, find the highest. So if I sorted it ascending, descending, I got the number of cards. I sorted it ascending is false, so I sorted it descending, the highest at the top. Well, the highest number of cards is 8. And let me go ahead and remove whatever was the highest one. And on this, if I ran this, let me go back and run this all fresh. Run that one. Find the missing data. I don't need that. I don't need to remove anything. Don't need that. Don't need duplicates gone. Let's go do the outliers and see the statistics on it. There's our statistics. Now it'll run for us. And we see that number 383, row number 383, has 9 cards. You know what? That's an outlier. Let me get rid of it. If I did that, let's say that number of cards was 42 and not 9. Yeah, clearly that's something. Let me get rid of that. I go input the 383 because I know what it is. I saw it up here at the top. And I'm just going to remove that from cards. I find 383 cards. I want that gone. And now when I run it, there's the head on it, but I want to run it this way and sort this thing out the way it was before. Now I see the highest cards is 8 and not 9 because I ripped that one out. So I can remove the outliers. And lastly, we'll talk about normalizing casing. Casing, we're not talking about the case like you put it in a case. This is casing meaning uppercase or lowercase. And it's just converting things to upper, to lower. We've dealt with this early on when we were dealing with strings. So now we're using something we've already learned to make sure that when you compare two strings and you go look for something, if the case is not the same in the comparison, it's going to throw an error, or it's going to say, oh no, these aren't the same. So we convert everything to a standard case, then there's no issue. And in this one, we took gender and converted them all to lowercase. In this one, we convert them back to title case, meaning upper letter or capitalization first. Something we dealt with before. Now we're just applying the concepts that we've seen in the past. So that's what the cleaning things up means. So that we cleaned it up, I could have taken this up a notch and turned student into a category 0 or 1, gender 0 or 1, married 0 or 1, and once I've done that, everything's a number. Everything's a number. Man, if it's numbers, it allows me to manipulate it or aggregate it or analyze it. It's a whole lot easier when we're dealing with numbers instead of something categorical, which is words. All right, I'll see you in the next one where we're going to deal with web scraping.